See, today we'll start with spring force. Suppose this is wall or fixed thing. This is spring connected to a block of some mass kept on table or anywhere. Here, this spring is in its natural length. NL means natural length. There is no extension or compression in this. Means when you pull the spring, it will have extension, and when you compress this, push, then it will have compression. There is a term K that is known as spring constant. Or you can say stiffness constant. Stiffness of the spring. This depends on the this is the property of the metal, like the spring is made of. So it may vary from metal to metal, or depends on the this spring is made of what metal, right? And we consider ideal spring only. Ideal spring only. It means that mass is 0, no mass, right? And because this it has no mass, so tension will be same everywhere in the spring, correct? Now suppose either you apply some force on this block, so this block will come, suppose like here, and because this block will come over here, so there will be some extension in the spring. So now this spring will look like this. There is some extension. Suppose from natural length, X is the extension in the spring. See, when it was in its natural length, there was no tension in the string. So tension in the string was 0. But when you pull this by applying some force on the block, there will be some extension in the spring. So now this string will have some tension. And that tension will be directly proportional to the extension. This is called Hooke's law. And just remove this proportionality constant, you will get K into X. This K is called spring constant or stiffness constant. You may also compress this by applying the force on this body. So this will be like something like this. Suppose here. And this is the from natural length, this is the compression. So again, tension in it will be directly proportional to the compression. And this is also known as Hooke's law. Right. See, when you pull this block, this spring will extend, and we know that it will have some tension, and we know that tension is always of attractive pulling nature. So it will apply some force T on this block opposite to the force that you applied, means extension. Now when you compress this, you just compress this. So this spring will push you like this. So in this case, this will apply force in this direction. This is fixed, so there is no sense of talking like force on this body, because even if this spring will pull this, nothing is going to change. Even if this tension will push the wall, nothing is going to change, right? So this is called Hooke's law. Correct? This is the property of K is the property of spring that I already told you. Okay. And also one more thing. See, suppose L is the natural length of the spring. So K will be inversely proportional to the natural length of the spring. Natural length. of spring. Means K is inversely proportional to length. If a spring will be larger, its spring constant will be less. If a spring will be shorter, its a spring constant will be more. Note it down till here.
Done, sir.
Today I have brought some of the fantastic questions that we'll do, but let's uh, let's understand this in detail first. Then, okay. Now, suppose if I take one example, see this is the spring. Nothing is hanging from this spring, so this spring will be in its natural length. There is no extension, no compression. Now, if you suppose hang some object here of mass n, now this is very obvious that this spring will get elongated, right? If you hang something, it will extend because of. So suppose after hanging this object, there will be some extension in the spring, and finally it will come to rest, right? So now we know that because of this object, this spring will get elongated by some length, and finally it will come to rest. So suppose this is the position of equilibrium. Equilibrium is rest. Position of equilibrium means no force, no net force. Now you can see that. If I ask you to find the extension in the spring, this is very obvious that you will think that after hanging the block, this block will try to go down because of gravity. So definitely this spring will experience some extension, right? It will have some extension. So finally, it will have some extension. Suppose X is the extension. So now this spring is extended. Now this spring will try to get in its original position. So now this spring will pull this block up. So suppose X is the extension. So the tension that this spring will apply is K into X, extension or compression, K into X. This is the force that this spring will apply. And one force that is acting here, that is mg. Now, because this is the position of equilibrium, so net force should be 0. So whatever force acting upward must be equal to force acting downward. So from here we can find x equal to mg by k. Understood? Clear? Write it down if you wish. Done? Noted?
Yes, sir.
Now, see, I'll ask you one question. This is the suppose ground or table, any table. One spring is kept like this, fixed at this end. Suppose if you put some block here of mass, suppose m. So it's very obvious that because of the weight of the mass, this spring will get compressed. Suppose the compression is x is the compression. Suppose it gets compressed by some suppose 4 meter. 4 meter is the compression. Correct. And spring constant of this is 100 Newton per meter. Find m. Tell me.
So just 40, right? Sir,
Why 40? 4,
so
4 kg, no?
so so mg equals kx. M into
Yes,
10 equals
yes, yes.
100
So,
into.
yes. So after putting this block, this spring will be compressed. Suppose this block will come over here. So 4 is this is the compression. Now, because this spring has compression. So mg will act downward, that is m into g. And because this spring is compressed, so it will push it up. So kx will be acting upward. And now this will come into equilibrium. So kx will be mg. K is 100, x is 4. Oh, 40, right. Mass this 10. Yes.
Yes, sir.
So m is 40 kg. Correct. Now, question is, let me copy from here. Try this.
So this is just the net force, right? F, so C.
Answer is C.
So just the net force, right?
Mhm.
Then it's C, sir.
C. Achha.
You have mentioned.
Wrong. A. C. Let me tell you. C. Two blocks of mass m are kept over a smooth surface. They are connected by a spring balance. Oh, spring balance? Okay, fine. Oh, this is the spring balance. I'll teach you. And acted upon by the two forces as shown. The reading of a spring balance means this is the spring balance. So the tension in the spring. Tension in the spring. Whatever tension this spring will experience. So that will be the reading of this spring balance. So now we can see that. So you need 2F minus F. That is net force, right?
Yes, so, but I don't think it's right because there's mass also given.
So just think that, see, this force is bigger and this is smaller. This is twice of this force. So of course, this body, this complete system will move towards the left, right? Suppose A is the acceleration. And suppose, like, there is a maximum extension in this spring because this force will pull it and this force is also will pull it in opposite direction. So a spring will face maximum extension, right? So at that maximum extension, like both the complete system will move with same acceleration. Suppose A is the acceleration towards left. So now if you draw the ability of this block, you'll have 2F towards left, normal from earth up, mg from due to gravity down, and there will be, because there will be extension in the spring, so spring will pull it like this. Suppose X is the extension, or you can say that just spring force. No need to find like this. Just a spring force, Fs. And if you draw the ability of this small block, F is acting like this here. Same spring force because spring is same ideal, and normal force and mg. There is no sense of this because this is moving horizontally. So see, because the system is moving towards left, so the net force has to be towards left. So for this, if you write 2F minus spring force equal to mass into acceleration, and here this is also moving towards left, so Fs minus F should be the net force towards left equal to m into A. You want to find Fs. That will give you the reading of the spring balance. So you want to find Fs. So just do just
So
subtract.
just equal it, sir. MA, you'll get it.
That is also work. So MA both are same. So this equal to this. So 2F minus Fs equal to Fs minus F. So 3F equal to 2 Fs. So Fs equal to 3F by 2. That is your reading. Understood? समझ में आया?
Yes, sir.
Archit?
Yes, sir.
Okay, noted now? Okay. Next question. This is multiple correct choice question. So more than one options may be correct. So you have to check all the options.
So,
Hmm.
so because they're connected like by a spring, shouldn't the acceleration be the same for both?
It will be.
So, sir, in that case, it should be one of the answers should be B.
That is fine. Okay. What else?
So, C.
Okay. What else?
What is that? I don't. That's all I think.
Archit and IOC?
Yes, sir. Maybe B and C.
Okay, very good. I think answer is ABC. I think. Wait,
So how
let
can it
me.
be A, sir?
Okay, I'll check now. Wait, wait. Where is the answer? Which question is this? Huh. Answer is ABC. How or why so? I'll explain it. See, mass is given. One force 4 Newton is acting on this body. Okay, now let's check first option. When acceleration of A is this. Now see, draw the ABD of A. First you draw the ABD of A. See, question says that this A has some acceleration. It means that there must be some force on it. And who will apply force on it? One may be normal from ground, one will be gravity, but this cannot provide acceleration along horizontal because they are acting vertically. So definitely a spring will apply some force, Fx, correct? There is only one, like no, only spring is there. So that spring, because because see, 4 Newton is applied on B. Because of that, B will want to move towards the right. Because of that, there will be some elongation, extension in the spring. Spring will have some force, some tension, and that tension will be same everywhere. So if this spring will have some elongation, so this spring will pull B like this and pull A like this. Okay, now, so this is the spring force. That should be equal to mass of A into acceleration of A. Mass of A is 1 kg and acceleration is 1 meter per second square. So the force is 1 Newton, means spring has tension 1 Newton. Now, draw the ABD of B. That is 4 Newton. Here, this should be tension due to spring, that is 1 Newton. And we have to find acceleration of B. So 4 minus 1 must be equal to mass of B into acceleration of B, that is 3 by 2. So first answer is correct. You can do the same thing with B. You will get B as well. Now, the acceleration of A always be less than or equal to acceleration of B. Correct. Why? See, initially there is no extension suppose. This force is applied on B. So because of that, B will try to go right. Because of that, B will pull this spring. So this spring will have some extension. That will keep on increasing till equilibrium. Equilibrium means the maximum extension that this spring can have. So if this spring will have maximum acceleration, at that moment, B and A will move with same acceleration. But suppose B just started moving towards the right. So this spring will have some force, some very small force. This force. And the same force will be applied to A as well. So if you see the net force on A, that will be Fs upon mass of A. This is its acceleration. But for B, it should be 4 minus Fs upon A, mass of A. So this should be the acceleration of mass. So of course, this force and this force is not same. So gradually, extension will increase. Gradually, extension will increase. So spring force will increase. So this force will increase, and because of this will increase. So this net force on B will decrease. So at some moment when equilibrium will be reached, at that moment forces on both the particle will become same, and at that moment acceleration will be same. Before that, B will move with more acceleration and A will move with less acceleration. So C is also correct. Understood? ये बात समझ में आया?
सर मुझे बी वाला नहीं समझ में आया।
मैंने क्या बोला कि देखो बी पे एक फोर्स लग रहा है, तो जैसे फोर्स लगाओगे तो बी राइट में चलना चालू करेगा। उससे क्या
Yes,
होगा,
sir.
स्प्रिंग में थोड़ा एक्सटेंशन आएगा, थोड़ा एक्सटेंशन आया तो स्प्रिंग में थोड़ा फोर्स आएगा, तो बी को वो अपोज करना चाहेगा। जितना फोर्स वो बी पे लगाएगा उतना ही फोर्स वो ए पे भी लगाएगा, क्योंकि आइडियल स्प्रिंग है। तो ए पे जो फोर्स होगा वो खाली स्प्रिंग फोर्स है, बट बी पे फोर्स क्या है, 4 माइनस एफ एस। तो ये अभी बड़ा है क्योंकि एफ एस बहुत छोटा है, तो इसका एक्सीलरेशन डिफरेंट होगा, इसका एक्सीलरेशन डिफरेंट होगा। और जब इक्विलिब्रियम पे आ जाएगा तो धीरे धीरे क्या होगा, इसका एक्सटेंशन बढ़ते रहेगा, बढ़ते रहेगा, बढ़ते रहेगा, बढ़ते रहेगा। एक मोमेंट आएगा, उस मोमेंट पे स्प्रिंग का मैक्सिमम फोर्स होगा और इक्विलिब्रियम कह देना है, मतलब दोनों से जो ब्लॉक है ना, वो दे विल मूव विद सेम एक्सेलरेशन। एट दैट मोमेंट नेट फोर्स ऑन बी एज वेल एज ए विल बी सेम। या कभी न कभी एक्स के किसी न किसी वैल्यू के लिए, एक्सटेंशन के किसी न किसी वैल्यू के लिए, बोथ ब्लॉक may have equal, may have forces in definite proportion, so that if you divide that force by mass of A and mass of B, then acceleration might come equal. But before that, acceleration of block A will always be less than the acceleration of block B. सोचो, इमेजिन करो, आएगा।
तो सर एक्सेलरेशन हमारा तभी इक्वल होता है ना जब दोनों मतलब स्प्रिंग अपना मैक्सिमम अटेन कर लेती
यस, वही मैं बोल रहा हूँ। यस यस
So,
यस।
so in the exam that we wrote on Saturday, I think, so sorry, Sunday, there was one question about like pulley, like two pulley systems in the shape of an M. So can you explain that now? Or like in the
Give,
end of class?
give me that question. I think you
Yes.
are giving SAT as well.
No, not SAT, sir. Saturday's test.
Saturday's test. Okay, I mean that I took.
Yeah, yes, sir.
I'll discuss. Don't worry, I'll discuss.
No, sir.
Tomorrow.
So like after class, I have a question that, so can we
But
do?
after class from 7:30, I have different 12th class.
Okay.
So
Sir.
you want to discuss today only, or tomorrow if I discuss the complete paper, that is okay.
Yeah, tomorrow's fine, sir.
Tomorrow I'll definitely discuss the complete paper. Don't worry.
Okay, sir.
Done, everyone noted? Okay, now let me ask you a different question. Next question. See, this is fixed wall. This is fixed wall. There is a block kept over here. Its mass is, suppose its mass is M. This is connected with this spring and one more spring. Spring constant of, initially this, see, if I write spring constant is K, both spring are same. It is in natural length. NL means natural length, means there is no extension, no compression. Natural length, and its length is L, suppose LL. Now, and I'll just release this system from rest. So the system is released from rest. Find acceleration of block this M when descended by X. Just try. Just take 1 minute. Try. Today, what I'll do, I'll just export the complete test in PDF and then I'll send you. You guys also go through that paper, see, do the analysis, and tomorrow I'll discuss the whole paper.
Okay, sir. So in this question, is it like forming a V? Like are they falling down? Is it falling?
Yes. Correct. See, also, as soon as you release the system, now, this M will fall. Suppose at any moment, this block will fall by x distance. So this is the level, reference level. It will come down x. At this moment, you have to find the acceleration of this block. See, this is the block. Spring will be like this. And it is but obvious that this length will be more than this length. So of course, string will have some extension. This is L, this is L. Now, this distance would be using Pythagoras, it will be L square plus x square. So how much is the extension? That will be under root L square plus x square minus L. This should be the extension in the spring, in both the spring, correct? So what should be the spring force? That is spring constant into extension, correct? Now, draw the FBD of this block. You can see that one tension will be like this. Both spring are identical, so both will have both have same extension as well. So both will have same tension as well. So this is the mg. Suppose this angle is theta, so this will also be theta. Now, if you break this into just break this force in two components. See, this will have t sin theta. This will be t cos theta. Again, this will be t sin theta, and in upward direction, this will be plus t cos theta. Now you can see that this will nullify this, and acceleration, it has tendency to go down, right? So suppose mg is bigger, mg minus net force in vertical direction 2t cos theta equal to mass into acceleration in downward direction. Now you just have to, this is spring force, that is your tension. Just put here and get the answer. Right? All right.
So can you explain the equation for spring force again?
See, the tension is acting along the spring, right? So here also both springs are identical, so both will have same tension. So you have two components, t cos theta, t sin theta, t cos theta, t sin theta. This horizontal component and this will nullify each other. Vertical, there are t cos theta plus 2t plus t cos theta, so 2t cos theta in upward direction and mg in downward direction. So at this moment, suppose this block has acceleration downward, so net force has to be downward. So net force would be mg minus 2t cos theta equal to mass into acceleration. And just
So,
put
so for Pythagoras theorem, wouldn't it be L square plus x squared minus L square again? So how did you do that, sir?
array, this is L and this is x. So using Pythagoras, this will be under root L square plus x square, and extension should be this length minus initial length. So this should be the extension. So force in a spring is that is tension is k into extension. All right.
Oh, okay.
Note it down. Sure. Before going further, like now I'll talk about some more thing theoretically. Before that, there is a very fantastic question that I want to discuss with you. Completely out of the box question. Completely out of the box question. You have noted this. तुम लोग अपना अपना वीडियो तो ऑन करो यार, क्या कहते हैं? सबका हो गया ना? Very fantastic question. Very fantastic question. Just read it once. पढ़ लो, पढ़ के बताओ समझा या नहीं समझा। शायना तुम समझा हम क्या बोला। शायना को कुछ नहीं समझा।
No, sir, I understood. You said read and then tell me if you understand.
हाँ हाँ। Now I'll solve. See, the question is like this is top plane. So suppose a horizontal plane, on this plane, a stationary vertical cylinder. See, a vertical cylinder on this is kept like this. And with the help of a rope, one bar is connected like this. And we provided a velocity V naught that is completely perpendicular to the length of this string. You can see. So what will happen? This will this rope will wrap around this cylinder, right? Wrap around with cylinder, right? Okay. And okay, this is the disc. And okay, what vertical cylinder of radius r, and it is attached to the cylinder. The horizontal thread. Oh, here is this is this. This is well, like this is this. Length is L naught. And initial velocity V naught is imparted to the disc as shown in the figure. The time it moves along the plane till it strikes the cylinder. So like it will wrap around this, and finally it will go and hit. That disc will go and hit the cylinder. So how much time it will take? That you have to find.
So I don't understand. Can you explain again?
See now, there is a cylinder. There is a cylinder. This is the rope. And one object is connected like this. Just give this, give vertical, this perpendicular velocity to the length of the thread. So this will go and it will wrap around the cylinder, and finally some length will get wrapped, then further, again and again. Finally, this will go and strike that cylinder. Understood? Now you have to find out how much time it will take to strike this cylinder. See, just imagine that. See, this velocity is imparted perpendicular to the length. So see, tension will always act along the string. So because this force is acting along like this, and velocity given is perpendicular to this, so this force will not change the velocity because this is perpendicular. So because of this velocity, it will revolve. Now, so see.
So what is the disc doing here?
This block, not disc means this is object, stone, something like that.
What is its function, sir?
No, nothing. A object is connected here, tied
Oh.
here. There is no other meaning of this.
Okay, got it.
Because if nothing will be connected here, you cannot give velocity to the end of the rope, and it will wrap this cylinder, right? Okay. Suppose this disc will come here at some time. So this will be some part of the rope will get wrapped here around the cylinder, right? And suppose this angle is theta. The angle that you will make with vertical is this angle is theta. At certain time, at t, and in dt time, this will come over here. So now this rope will become like this in dt time. So this angle will become d theta. This angle will become d theta. Or you can say that this angle is also theta, or this angle will be d theta. Because this is theta, this is 90, this is 90 minus theta, and whole thing is 90. So this is theta. Now, see, so initially the length was from here to here, the length was L0. But after some time, some part of this row will get wrapped. So suppose this part of the row is got wrapped. So what is the length of this part? What is the length of this part of this string? So you can see that this is R. See, this is 90, this is theta, and this is R. So this should be R sine theta. So this length will be how much? L0 minus R sine theta from here to here, because this part is R sine theta. And it is like in a circle, theta equal to L by R. So if this angle is d theta, so what would be this length? That is suppose dl. So dl is theta by theta into R. So that is d theta into R. R means this radius. बोलो ये समझा? थीटा इक्वल टू एल बाय आर. अर्चित उतना उदास क्यों है? अर्चित क्या हुआ?
नहीं सर कुछ नहीं.
समझ में आ रहा है?
हाँ.
साइना तुम समझा? Okay, so this is the radius kind of here in circle. What you do? So this is R, and this is suppose L. This angle is theta. So theta equal to L by R, like that. So this length would be dl is d theta into L naught minus R sine theta. Okay. Now this velocity is v naught. So now you see, and this v naught is constant because there is no force acting along this velocity. There is no friction. So this will remain constant. So this dl can be written as speed into time. Time is dt. That is L naught minus R sine theta into d theta. Just integrate this. Just integrate this. So initially it was at rest. So 0 to t, total time it will take. And now when it is at this position, the angle the value of theta would be 0. And suppose on this cylinder, it will get wrapped at some certain angle, right? Some length will be like, it will come and wrap here, like, this will come and strike. So this angle will find how much? Suppose this will come and here, this will strike here. So this angle would be how much? It will move on circular path. So suppose theta, suppose alpha, at some particular alpha, it will come and wrap. So that distance would be how much? L naught by R. Theta equal to L by R. Right? This angle is alpha. Here it was connected and it will strike over here. So this distance is how much? L or L naught. So this is R. So theta equal to L by R. So alpha is L naught by R. So this angle will be L naught by R. Just integrate this. V naught will come out. This is constant. Integration of dt is t, upper limit, lower limit. Now integrate this. So L naught into theta. L naught is constant. It will come out. Integration of theta is theta. minus r. Integration of sine theta is minus cos theta. And then put this limit L naught by r in 0. Now this is V naught. Put upper limit first minus lower limit. So this is t equal to L naught. Theta is upper limit is L naught by r plus r cos of L naught by r. And if you put lower limit minus 0, it will be 0 and then r cos 0 1. So r. Now you have to find where is V. There is no term of V. Why so? Okay, let me calculate this first. So this will be L naught square by r, and here it will be r. Just take minus r common, it will be 1 minus cos L naught by r. Now apply the formula. Cos 2 theta is 1 minus 2 sin square theta by 2. So it will be L naught square by r minus r into this will be 2 sin square theta by 2 L naught by 2r. Right. Now, if I consider this angle is very small, if sin theta is very small, sin theta can be written as theta approximately. So this should be L naught square upon r minus 2r into L naught by 2r whole square. So here it should be L naught square by r minus 2r into L naught square by 4r square 2 gone r gone. So this is L naught square by r minus L naught square by 2r. So it should be L naught square by 2r. So V naught t is L naught square by 2r. So t should be L naught square upon 2 V naught into r. So if you match this with, so I think V naught is missing. There should be some type. So x should be 2, I guess. X should be 2. Let me match the answer. Correct, 2. That is missing, I think. T naught square by 1, 2r V naught, correct.
Sir,
Hmm.
so can you explain this step again? After 2 sine square L naught by 2r, from after that, how did
Here,
yeah, after
see,
that.
if theta is very small, sin theta can be written as theta. Or tan theta can be written as theta, if theta is very small.
Okay.
So I just put sine, this is square. So sine this theta equal to theta. So theta is L naught by 2r and then square this and then solve it.
Oh, okay.
I mean,
No, so
I
how
can
did
see your,
oh, okay, got it, sir.
I can see all of your face, but I think that समझ में नहीं आया. Imagine करो ना. See. This is cylinder and this is the row. This is the row, till here. One object is like connected here. Now, when I give the velocity perpendicular to the length of the string, this will move like this. See, the string is getting wrapped here around the cylinder, right? Suppose this object has come over here. So now this part means till here. Suppose this part got wrapped. Now, see, this part got wrapped. So this part, we can see that if you draw the line, so this part will get wrapped. So you have to find. So this part is this. This part is this. This part is this. That we found using this triangle. So suppose at any time this makes some theta angle. This will make some here now. Right now it is horizontal, and after some time it will go like this. So some angle will be made here, and dt time further it will make d theta angle. So at any moment, initially the length was L naught. Now this part, suppose this is cylinder, so this part will get wrapped over here. Now this length will be remaining. So this length should be how much? This is r sine theta. So this should be how much? L naught minus r sine theta. And now in d theta time, dt time, this will move further d theta. So theta equal to L by r. This distance, this dl should be radius of the circular track into L naught minus r sine theta. And like that, for that we got the time dt, that is this distance upon v, like this. And then because every time, like the length will keep on decreasing, so I just integrated for a single element. We found that, and then I integrated. So for all the elements, this element plus this plus this plus this, so addition is called integration. Is it okay now? Very tough. क्या बातचीत आयुषी साइना कुछ भी नहीं समझा अभी तक नहीं समझा साइना you didn't get
So
understood
I don't understand one part. How did we get L naught minus R sine theta?
see na see this is the cylinder. Here it is, this length is like this. Now after some time, when this length will be like this, so you can see that this part will get wrapped, this part of the rope will get wrapped on the cylinder. So I'm talking in a very small time, dt time. So in dt time, this will be a straight line only. Consider this as a straight line only. So this length will be wrapped. So this is r, and just
Okay.
connect this. So center and radius. So this will be perpendicular. This is r. This is angle theta. So r d theta, r sine theta. Understood?
Yes, sir.
It was a very good question. Note it down. Let me know once noted.
सर थोड़ा स्क्रॉल डाउन करेंगे.
अर्चित क्या हो गया? वीडियो
डन
ऑफ
सर.
करके क्या कर रहा है?
क्या सर?
अर्चित वीडियो क्यों ऑफ कर लेता है?
नहीं सर, वो जरा पानी पी रहा था, एक मिनट।
तो पानी ऐसे ही पी सकता है। समझ
नहीं
में
सर,
आया?
हाँ आया, थोड़ा बहुत आया।
घर पे वापस से ट्राई करना, नहीं
हाँ, वो
समझे
एक बार
वीडियो
वीडियो
फिर
देख के वापस से देखूंगा फिर।
हाँ, वीडियो फिर से देखना। और सी, इमेजिन करो, जस्ट इमेजिन इट कि हाउ थिंग्स आर गोइंग, सिचुएशन क्या है। क्योंकि like from this year, like experts are saying that in IIT, like they have started asking questions which will be out of the box thinking, that will check your out of the box thinking IQ level. How do you think that? How do you think? How do you analyze the situation, right? Okay, fine. Now see, next thing is, suppose, see, uh suppose this is the fixed wall and this is the table. Suppose this is the string and this string is tight, this string is tight and block is tight, right? So suppose, even if you suppose, like one force is applied over here. Because of this force, this string will have some, see, understand, this is concept. So because of this force, this string will have some tension. But as soon as you cut this, as soon as you cut this string will have tension 0. As soon as you cut the string, as soon as you cut the string, the string will get slacked. The string will get slacked, so it will have tension 0. Now let's talk about the case of spring. Again, suppose this spring has some tension. I mean, suppose this, you apply some force. Because of this spring will have some extension and hence it will have some tension. Correct? But as soon as you cut this, now analyze the situation like this. One end will be connected here and this part is like this. So this, from here you have cut. And there is another part that is connected to the block. Now you know that force is mass into acceleration. Force is mass into acceleration. Force is mass into acceleration. Now see here, as soon as you cut this, there is no mass connected here. There is no mass connected here. So the acceleration will become Fs upon 0, means infinity. It means that as soon as you cut the spring, this end of the spring will have infinite acceleration. So with very fastly, it will go to its original position. Means it's a natural length in a very fraction of second. It means that as soon as you cut the spring and it will go in a fraction of second, it will get into its original position, natural length, means no elongation, no compression. And if it is in natural length, means it will have zero tension. So again, this will have zero tension. Understood? So as soon as you cut the spring or a string, tension will become zero. But now analyze the situation this. Spring, block is connected, string, and this is fixed to this end. Suppose this system is in equilibrium. As soon as you cut this string, as soon as you cut the string, as soon as string is cut, tension in it will become zero. Tension in it will become zero. As soon as you cut the string then. So string will get slack and tension will become zero now. But once you cut the string, what do you think? What would be the tension in a spring?
It'll increase, sir. Like downward
No,
force.
I'm talking about just after cutting the string. Just after cutting the string.
वो स्प्रिंग स्ट्रेच होगा.
No change in tension in string. See, analyze the situation. In a previous case, I told you that no mass is connected on the where you cut the spring like this. Here, it was no mass was connected. So this end will have infinite acceleration. So in a fraction of second, it will go into its original position and tension will become zero. But here, mass is connected.
सर
this
अगर
point-
इसमें अगर टेंशन स्ट्रिंग का हट जाएगा तो फिर वो सारे स्प्रिंग का लगेगा और ब्लॉक उसकी तरफ शिफ्ट हो जाएगा.
That is fine. That is fine. But I am not talking about that. I am talking about the tension in the spring. So before cutting and after cutting. And I'm saying you that just after cutting that row, just after cutting the row, no change in tension in spring will happen because here mass is connected. See, no, I'm not saying that tension will not change in spring. I'm not saying that. Tension will definitely change, but it will take some time. It will take, tension will definitely change, but it will take some time. Point is just after cutting. Just after cutting, tension in spring will remain same. Understood? Tension in spring will definitely change, but just after cutting this string, tension will not change. So tension in the spring will remain same. Just remember this fact. Note it down. Done? Note.
So just a minute.
तो आयुषी कहाँ दिया पटाखे? वो एरोली में जो पटाखे का वो जो शॉप लगता है ग्राउंड में, वही ना?
नहीं सर, कुछ कुछ तो हाँ वैसे ही लगते हैं, बहुत सारे वहाँ पे लग.
तो वहां पे उतना एग्जैक्टली तो नहीं आता, बट मैं वहीं आके लेता हूँ हमेशा पटाखे.
Sir, can you go to the
Thanks.
previous slide again?
Previous slide. Have you noted it down?
No, sir, I need to take that first and then I'll come to this.
Then there was there was nothing in there.
Oh, okay, I'll just do this. Then.
Huh? Okay. कल भी मैथ में एक बहुत टफ क्वेश्चन दे दिया, आज भी फिजिक्स में बहुत टफ क्वेश्चन दे दिया.
Done, sir.
Okay. One question. This is the ceiling. Spring. This is spring. One mass is connected here. That is 2 kg block. And spring. There is one more block is connected by string. Suppose no. Wait. This is not 2 kg. This is simply mass is m. This is also m. Spring constant is q. Right. System is at rest, equilibrium. Find tension in spring and string both. First thing is this. See, first we have to find tension in spring and string. That is fine. See, draw the ability of this body. So this will be like,
Sir, can you give us 2 minutes?
okay, fine.
सर जो स्ट्रिंग है वो लास्ट वाले ब्लॉक से टाइड हो रखी है ना, मतलब उस तरफ खींचेंगे ना.
This is a string, this is a spring.
आंसर न्यूमेरिक में है या फिर और मतलब वैसे?
Let me now solve. See,
क्योंकि स्प्रिंग टेंशन से
I'll
मेरा
draw the FBD.
ट्वाइस
हाँ,
ऑफ mg आ रहा है.
हाँ, वैसे ही कुछ है. mg string will have some tension. Suppose T1 here. If you draw this, the diagram of this free body diagram of this body, you can see that this gravity will act downward, and this string is also connected to this. So this will have T1, and above spring is there. So spring will have tension T2. Now this is at rest. System is at rest. Nothing is going to happen. So T1 must be equal to mg, and here T2 upward and T1 plus mg downward. So T1 is mg here. You can put. So the tension is 2 mg. Understood?
सर
Clear?
यही आ रहा
Everything?
था.
हाँ, perfect. IOC आ गया है sir. Sana, you got the same thing?
So I got T1. I got confused with the constant, so I didn't do that.
Constant, which constant?
They've given spring constant, so I assumed you have to use that.
Okay, that is fine. You can also take it at kx. That is fine, but that is T2 actually. We are
Yes,
not
I
supposed
got,
to find extension. Huh?
yeah, I got
Suppose
missed.
okay. In case suppose you are asked to find extension, then you can use in that case k into x.
Yes, sir.
Okay, fine. Now, next question is, this is very simple. Next question is, find acceleration of blocks just after cutting string. Now try, giving you 2 minutes.
So are they like simple answers or are they like complex?
सर 2 and 20.
No. See,
So,
I'll tell you.
so is
Huh.
acceleration of the string mass just mg, and for the spring one it'll be 0?
Very good. I see you got the same thing. Okay, I'll explain. See, so as soon as you cut the string, you know that as soon as you cut the string, tension will become 0 in a string, right? So for this body, this T1 will become 0. So only mg will be acting on this body. So it will come down with acceleration how much? G, na? Divide by m, so G. But for this, you can see that after cutting this string, tension in a string will become 0. So T1 will become 0. So this T1 will become 0. So initially you can see that on this body, T2 was acting upward and mg was acting downward, and also there was one more force that was T1. So because now it was in equilibrium. So T1 equal to T2 equal to T1 plus mg. Now you can see that string is cut. So because of that, this will become 0. Now force acting downward will be less. Force acting downward will be less. So net force would be upward. So T2 minus this force upon mass would be acceleration, isn't it? And T2 you have 2 mg. So just put 2 mg here. 2 mg minus mg upon m. So g. So the acceleration of lower block will be g downward, and the acceleration of upper block will be g upward, isn't it? All right, China, IUC. Okay, note it down.
Answer.
Now, scenario is opposite. Here is a string. This is mass M, and a spring will be here. Now, same thing. First question. Find tension in spring and string. Second, find acceleration of blocks just after cutting string. Just after cutting string. Solve it. Just name it like block A, block B.
So are the tensions the same as the previous question?
Sorry,
For the tension values, is it the same as the previous question?
yeah, might be. Yeah.
सर टेंशन मतलब एक्सेलरेशन ऑफ फर्स्ट टेंशन की इंफिनिटी एंड सेकंड की मेरे ख्याल से वापस से जी आ रही है शायद
Okay, okay, okay. इन्फिनिटी कैसे आए?
सर एक्स मतलब स्प्रिंग कटी तो फिर वो
स्ट्रिंग काटा है, स्प्रिंग कहाँ काटा है? स्ट्रिंग काटा है, स्ट्रिंग.
अच्छा स्ट्रिंग अच्छा अच्छा ठीक तो सर जीरो और जी
लग रहा है ऐसा ठीक बोल रहे हो उसे.
सर सारा तो सेम ही है पिछले क्वेश्चन से
कौन? सारा मतलब सारा अली खान.
मतलब सारे मतलब सारी टर्म
अच्छा.
सेम आ
ठीक है, see, I'll do. Draw the ability of this block. One tension is acting upward, mg is acting downward, and this will also have a spring, some tension, so T2 down. Here T2 and here mg. It is in equilibrium. So T2 is mg. It is also at equilibrium. So T1 equal to T2 plus mg. So mg plus mg. So T1 is 2 mg. Simple thing. Okay, now as soon as you cut the string, this is now you can see that this T1 will become 0. This T1 will become 0. And there is only one force now. And on the upper block, block A, T2 is acting downward and plus mg. So T1, right? T2 is acting downward plus mg. Okay, now and here on this block, M, B, to T2 is upward and mg is downward. Now what will happen? Tell me what will happen? Tell me. Initially it was T1 upward.
So it'll just be divided by mass, T2 plus mg by m for acceleration.
So this T1 will become 0, right? And at equilibrium, if you see T2 equal to mg, so there is only one force, T2 plus mg acting downward here. And what was the value of T2? That is mg. So total would be mg plus mg, 2mg upon mass. So 2g, that is downward. And here, if you see T2 equal to mg. So T2 and mg both are same. So acceleration of B is 0. Because as soon as you cut the string, there is nothing going to change in spring. The tension in spring will remain same. So T2 equal to mg will remain same just after cutting the string. Understood?
Sir, we can't say simply that after cutting the string, the acceleration would be 0.
No, no. That will be wrong. Noted, everyone? Okay, now next topic, weighing machine. See, weighing machine measures normal force. We generally call it weight, that is mg. See, suppose this is the weighing machine kept on railway station, weighing machine. You stand over here on this. So if you draw the ability of yourself, you can see that two forces will be acting on it. One, normal duty weighing machine, and other, gravity, mg. Understood? And if you draw the ability of weighing machine, whatever normal force that weighing machine applies to you, same normal force you apply on weighing machine. So this is your reading. This is the reading given by weighing machine. So N is mg. See, this is force, but you get in kilogram, right? So basically what happens, this is the internal calibration, that is internal mechanism. So you get what reading of the weighing machine you get in this form. Reading is normal force upon G. This is how, the coding of the weighing machine is done. And this is called kgf, means kilogram force. Kilogram force. 1 kgf is equal to 10 G. Sorry, 10 Newton, or you can say more precisely, 1 kgf is G Newton. So approximately 10 Newton. That's it. This is the theory of weighing machine. Nothing more than that.
Sir, kgf is a reading unit.
Unit.
But sir, if force is divided by acceleration,
You get kg.
kg.
Like you get 50 kg, 30 kg, but we call it kgf, kilogram force. Noted? Noted? Okay. Noted, guys? Okay, now see, there is a lift. In this lift, a man is standing on the weighing machine. Mass of the man is m. This lift is going upward. Find a reading of weighing machine. Other scenario is this lift is coming down with acceleration A. This is a weighing machine. Man is standing over. See, in this first scenario, if you draw the FBT, so you just have to find like a normal force applied by this man on the weighing machine. So whatever normal force, if you draw the ability of man, normal force, whatever normal force this weighing machine will apply on man, same will be applied to weighing machine as well. So you have to find the value of n, cmg. You can see that this lift is going up, so this man is also going up. So n, just apply the Newton's second law. N minus mg equal to ma. So the n is mg plus a, means effective acceleration. So this is your rating. Here, if you see, n upward mg downward coming down. So here it will be mg minus n equal to m. So n will be mg minus. So here different reading. Here different reading.
So
Hmm.
in the second case, wouldn't they experience weightlessness? So reading will be 0.
Yeah, same thing, na. G minus a. This is less, na. G plus a is more. So weight loss here.
Oh.
All will be in kgf. So this is normal force. You just have to divide by g. Done, noted. Okay. Next question. I'll give you. See, there is a lift. No, I'll solve. Don't worry. This is a lift. This is a weighing machine. One man is standing over here. Mass of the man is m. And m, the value of m is 60 kg. And suppose this lift is going up with some velocity, right? Lift is going up with some velocity. And velocity will keep on changing like this, as per this graph. Velocity will keep on changing as per this graph. This is v and this is t. Velocity is in meter per second, time is in second. So like this. Like this. So this is 0 and this is 10, this is 20 and this is 30. And the maximum speed that it can have is 20. So basically, you have to find the weighing machine reading and draw a graph between weighing machine reading and time. I'll solve it, don't worry. See what will happen. You can see that this velocity, the speed is increasing 0 to 10, and from 10 to 20, speed becomes constant, and from 20 to 30, speed is decreasing. Now, if I talk about t equal to 0 to 10 seconds. So here we can see that the speed is increasing. It means that it will have acceleration. This lift will have acceleration. How much acceleration? So acceleration is slope of the Vt graph. Acceleration dv by dt. Acceleration is dv by dt. Means delta v by delta t. V final minus v initial upon t final minus t initial. So final velocity at t equal to 10 is 20. Initial 0. T 10. So the acceleration is 2 meter per second square. Okay, fine. Now in this case, we know that acceleration is 2 meter per second square. So this is going up. So if you draw the ability of this man, normal is acting upward. 6 gravity acting downward. So 60 into G, 600 Newton, and going up with 2 meter per second square. You have to find normal. So N minus 600 equal to mass into acceleration. So the reading of the weighing machine would be 720 upon G. You can say that upon G, kgf. Understood? So you can say that 72 kgf. You can see that actual weight of the man is 60 kg, but observation says that it is 72 kg. So higher mass. Understood? Note it down. Note it down. Are you guys solving Anavasti? Atomic structure. Are you solving, everyone? अर्चित नहीं सॉल्व कर रहा है तो क्या कर रहा है अर्चित फिर
सर संगीत
अच्छा संगेज तो करो ठीक है थोड़ा देखो क्या करना है अपने को वी हैव टू बैलेंस ऑल दी सब्जेक्ट्स तो बैलेंस करके चलेंगे एवरीवन राइट फ्रॉम
सर
द
अभी
बिगिनिंग
दिवाली की छुट्टी पड़ी तो सर सब हो जाएगा अभी तो
हाँ ठीक है बढ़िया है तो राइट फ्रॉम द बिगिनिंग वी हैव टू बैलेंस ऑल दी सब्जेक्ट्स एंड में हमें मुश्किल नहीं होगी तुम देख सकते हो ना कि आई एम गिविंग यू very complex questions from beginning only so that like temperament would be will be like this ऐसा नहीं होना चाहिए कि in the end like I'll give you a complex question then you will get frustrated like no I cannot do it. Okay, done. Now see, so 0 to 10 we can see that in this part if time is 0 to 10 we can see that the normal reaction is 72 kgf. Okay, fine. What about time? What about time? 10 to 20 seconds. See, in this interval, velocity is constant. It means that acceleration is zero. Velocity is constant. It means that acceleration is zero. Now, if we draw the FBD, normal upward, mg downward, and there is no acceleration, bacha log. It means that net force must be zero. So normal is mg. That is 600 Newton. So reading would be how much? 60 kgf. So if T is between 10 to 20, actual weight it will give you. And for T equal to 20 to 30, you can see that velocity is decreasing. So if you find acceleration, what is acceleration on VT graph? That is slope of the graph. What would be the slope? This tan of this angle. Tan of this angle. So if this angle is theta, so this will be 180 minus theta. How do you find theta? So tan theta you will find perpendicular upon base, perpendicular 20, base 10. That is 20 upon 10. That is 2. And slope is tan of 180 minus theta. So that is minus tan theta. That is minus 2 meter per second square. Now, if you draw the FBD, you will get tan upward, mg downward, and acceleration is downward, 2 meter per second square. So write Newton's law, mg minus n equal to m into a. So n would be m g minus a. M is 60 kg, g 10 minus 2, that is 8. So 480, it means that 48 kgf. 48 kgf, understood? Now, so for T 20 to 30 bacha lo, normal will be like 48 kgf. This is N1, this is N2, this is N3. Note it down. Noted? Now, if I draw the graph, reading versus time. Reading versus time. So from 0 to 10, 20 and 30, you can see that 0 to 10 reading is 72 kgf. So here is 72 kgf. And after that 10 to 20 it is 60 kgf. 60 kgf. 20 to 30 there is 48 kgf. So 48 kgf. That's it. That's it. Done, noted? See, the next part is spring balance. See, this is very easy, like, you just have to find the tension in the spring. That's it. Suppose you have, we know, we have seen this kind of spring balance, like, here a spring is connected with some hook, and like, whatever you want to weight, just hang it here, and whatever, like, tension it will, suppose, I hang one mass of M, and you have to find the reading in the spring. So it's very simple, na? Mg due to gravity and tension in the spring. So T equal to Mg. This is this reading in the spring balance, right? Now that's it. Nah? Nothing else. Nah? Very easy. So let me take one question.
So
And
one minute, you go back. I couldn't even do quick.
okay,
Okay, got it, sir.
China. Okay. Now see, this is spring balance. Sorry, this is a lift. You guys will solve it. I know. You'll. This is the spring. This is the lift, and this lift is suppose going up with some a equal to 2 meter per second square, and one weighing machine is kept over here. This is a weighing machine, and suppose one man is standing over here. Mass of the man is suppose 50 kg, and suppose one spring balance is, and this man is just hanging in the hook of the spring balance. This is the spring balance, right? And no, this acceleration is not given. With some acceleration, this lift is going. What is given is a reading of weighing machine is given, that is 40 kg, and a reading of spring balance is given 20 kg. You have to find acceleration of the lift. Just try this.
Sir, 2 meter per second.
Very good, very good. I see rocks. हो गया अर्चित शाइना? अरे see ना, see reading of weighing. So draw the ability of this man. So see, weighing machine gives you what? Normal force. So weighing machine will apply one normal force. That is how much? 40 kgf means 400 Newton. Multiply by 10. That is G. And reading of a spring balance. So reading of a spring balance is what? Tension in the spring. So tension. This will pull this man up. Tension in the spring. That is 200 Newton. 20 into G. kgf में है ये से. And mg is acting downward, that is 50 into g, 500 Newton. So net force would be what? 600 minus 500. 100 Newton up, that is equal to mass into acceleration of the lift. So A is 2 meter per second square. Correct na? Simple na?
Sir, I thought
Ah.
you said mass was 30 kgs.
This is 50 na?
Oh, it's 50. So I got the same thing. I took it as 30, so I kept getting something else.
Okay, no problem. So now I hope like you guys have understood till here, right? One part is left,